Happy New Year, everyone, and welcome to the first set of data science office hours for Springboard for 2017. I'm Ryan Rosario, and I am a host for your office hours, and I am a data science mentor for the intensive and career track. This week, we have a very special guest for our career-oriented office hours and Q&A. AJ, one of the mentors here at Springboard, will be taking your questions and my questions. So how this works is we have an hour for this session, and throughout the session, go ahead and type in your questions for AJ as we move along into the chat box at the right side of the screen. We will answer I'll choose questions and we'll answer as many as possible. Given our audience today, that's pretty likely. You can also, if you find a good gap to ask a question, you can also get on mic. There's also an interesting raise hand feature that you can use. So if you don't want to interrupt, you can always use the raise hand feature, and we'll call on you as soon as we can. So to get started, AJ, tell us about how you got into data science, starting from the beginning and kind of where you are now, and then if you want, kind of dovetail into what you do now.
Okay. Well, first of all, thank you for inviting me to come to this session, and thank you for calling me very special. I've never been called that way before. So the way that I began working on data science was a little bit followed by serendipity, as they call it here. So, of course, I have a lot of friends that are in the IT area, right? So I'm a software engineer, and friends that I went to school with, professionals that I've met, etc. Every once in a while, we get together, and people start talking about stuff. And so there was a recurring theme, which was this machine learning. Of course, in my grad studies and also as a professional, I've used artificial intelligence, and they were trying to relate it to artificial intelligence, but the machine learning theme was kind of recurring, and I was getting curious. So that was around 2012, and then at the same time, I got an email about this program that was being put together, a distance education that came from Stanford. Of course, that we know it now as Coursera. And so I read the description of the course, machine learning, and I thought it was pretty cool that I will be able to, to take a course with a well-known professor from Stanford for free. And then I just gave it a try. So that was in August 2012, I think. So it ran from August 2012 to October 2012 or something like that. And I just fell in love with it. I mean, and I guess that the reason why I fell in love with it is because I discovered, after thinking that I didn't know anything about machine learning, I discovered that I had actually done some machine learning in the past. Because in one of my early lives, I worked in numerical analysis, solving partial differential equations that model the flow of fluid in porous media, which is a problem that is very important in petroleum simulation. Mm-hmm. So some of the things that they talked about in connection with numerical linear algebra, least squares, indirectly talking about solving linear equations, I was familiar with it, and I was really hooked into it. I was actually very, very surprised, positively surprised with the quality of the course. Of course, we already know that Stanford is a high quality educational institution and research as well. But I've seen other courses, and not necessarily the fame of the person who is offering it it equates with the quality of the course. So this course was really, really good, extremely good, because Professor Ang found a really, really good kind of sweet spot to combine things that have to do with the practice of machine learning, the fundamental mathematical elements, to a point that it was not that kind of in the way. So, I mean, he found a really, really nice balance of things. And I was so into it that I wanted to start kind of practicing it. And since 2012, I started trying to look for projects. And at the beginning, it was a little bit difficult. I think my first client in the area, I secured it in 2014. And since then, I've been working in the area. So that's kind of a long story.
Yeah, so it was interesting that you mentioned serendipity. I think that's pretty common in this field. At least, that's what happened with me as well. I was studying statistics. My goal was to go into educational statistics, and work for ETS or the College Board or the people that write the SAT and whatnot. But along the way, I wanted to also get better at coding and learn more about computer science because I'd always been in computers, and back then there wasn't a label of data science. So I kind of ended up doing both statistics and computer science, and it ended up being data science. So I kind of got lucky there. But now it's a field people can choose. So, that's good. What do you wish you would have known when you first started your career in data science?
I'm going to answer that question from kind of a more philosophical standpoint,
Sure.
Right? So when I get interested in a topic that I want to study, precisely one of the things that attract me is that I know nothing about it. So I go completely, open arms, trying to embrace whatever it is that I'm trying to learn. So I usually don't come with any expectations other than, understanding what it is. In a certain way, that's exactly what happened, right? So people were talking about machine learning. I didn't know what it was. And then I said, well, I have time to kind of know about it. And I didn't really go with any expectations. I went with, completely empty hands. I think that there is something that says that only empty hands can be filled with something, right? So if you think that your hands are already full, maybe you will be missing the opportunity to actually get something that you can get. That's kind of a philosophy of life, if you will.
So a lot of our mentees and students plan to go into data science as a career. And what are some of the things that you've noticed that are common mistakes people make when they go into data science? So let's say, somebody comes out of this program, becomes a junior data scientist. What are some of the pitfalls that they may experience or some of the common mistakes that they may make?
Yeah, I actually talk about that a lot with all my mentees. So let me start by saying that when I hear the term data scientist, and maybe some of them are already here, so I'm sorry guys or ladies if I'm repeating myself. So when I hear the term data scientist, I really want to hear professional data scientist. And the reason why I want to put the term professional in front of it is because the term scientist has this connotation that is really, in a certain way, academic and sometimes purist. So people who are looking for the truth, but more for the sake of the truth itself, and not necessarily for the sake of how that truth can be applied, right? Just to discover the truth and advance knowledge in general. A data science professional is really a service provider. So there's somebody who has a question, and that question to that person is extremely important because it belongs to what is called the bottom line of whatever organization the person belongs to, right? So you got to give respect to that. So the person comes to you because the person has a need, and the need translates to answering questions, and the answering of that question needs to be connected with solving a data science problem. So that's a very important element. Never to forget that we're professionals. And I always give the example to students that when you're a patient and you go to the doctor, you want for the doctor to have you as his or her main concern. So the same way should happen when we become that professional giving a service to our clients. So our center should be the concerns of our clients. And that's an important, that is an important thing, because since we love so much technology, for instance, we might be drawn naturally to the technological aspects of whatever we are trying to solve, the cool algorithms that we are applying, the cool tools that we are using, and we might actually miss the center of the attention, which is to actually answering the question of our clients. So that's something that is actually very important. I always, not always, but sometimes I refer students to a very interesting example that is discussed briefly in the book on data mining by this professor from Stanford, Ullman. I don't remember the second author. I think it's the mining of huge data sets or something like that.
Yeah.
And then he's trying to make the point that it is very important to understand the type of problem the client is interested in, and to determine if indeed things like machine learning, etc., are appropriate to solve these problems. So he mentions a company that they went with the idea that they would be able to use machine learning to solve the problem of matching needs of prospective employers to prospective employees. And the company failed miserably. They lost around $25 million and they closed doors because they couldn't find that solution using machine learning. And I think that the argument is that, they went with the technology first without actually thinking of the problem that needed to be solved, right?
That's excellent advice. And I know that a lot of people, myself included, coming from either a technical standpoint or from an academic standpoint, we want to always try new things or new technologies, and we can easily get carried away, focusing more on learning these new technologies and these new things, and not actually answer the question that the client is interested in. So exactly. Yeah, for a junior data scientist, if you're of that same kind of flavor where you kind of want to learn everything, focus on when to stop and when to return to answering the client's question. That's very important, and I struggle with that early in my career. So yeah, that's a really good pitfall. Throughout your previous response, you mentioned a lot about working with the client and whatnot. And one thing that I always hear, and is sort of debatable from my standpoint, is that a data scientist needs to have really strong, I shouldn't say really strong, but should be familiar with business skill, or should be business minded or business oriented in what they do. And the reason why I kind of hem and haw about that is because I've worked more as an engineer, where I'm usually working with a manager or an executive or a product manager who they're more worried about the business side. So I was wondering if that's also been your experience, or is it really important for all data scientists to have business skill, or has it been your experience that it helps in certain cases?
So it depends on the scenario, right? So in large organizations that are really specialized and they have a lot of resources, most likely there are other people who are working with you as part of a team. So there's a team in charge of moving a project forward, and different people pitch in different areas, right? So most of the time in those cases, there are roles that are either like user advocates or something like that, and business analysts, etc. So those would be the ones that are going to be like close to the client and making sure that the client's needs are satisfied. So in those cases, you can certainly focus only on the technical aspects, engineering aspects, etc. And as you mentioned before, you'll always be under some sort of a management or supervision that will always, also help you to be on track, right? So that would be the easy case. The most difficult case is in organizations that are smaller, when you have to play different roles. And examples of those include small businesses and startup companies, right? In both cases, the amount of resources could be limited in comparison to large organizations, and also the deadlines tend to be very aggressive. And that's what kind of prompts the need of wearing different hats. So in those cases, even if you don't want to, sometimes you have to kind of play that role where you are the advocate of your client, right? And making sure that there are two fundamental things, right, in connection with that. Is number one, that you are capturing the right requirements for the project, and that the project that is being developed is capturing actually those elements. So in software development, there is this term that says that you have to do the things right and you have to do the right things, right? So you need to build the right product and you build it right as well, right? So the two things are important. So there's no point in having an extremely sophisticated product with the latest of the technology, et cetera, and nobody's going to use it, or if the cost was too big, right? Mm-hmm. For instance, that happened a lot at the beginning with healthcare, when all of this craze about electronic medical records, etc., and everybody moving to IT. So one of the things that were happening is that doctors were rejecting a lot IT solutions because they didn't find them useful. They felt that they were like an impediment instead of helping them advance their business or whatever they were doing. Mm-hmm. So in those cases, then you have to have that type of a skill set in you that would allow you to kind of align with the needs of the client.
Mm-hmm. That's really interesting, and it makes perfect sense. I've worked at a couple startups. One in particular was very small. And what was kind of interesting, that could fall into the category where you really have to wear a lot of hats. In terms of the business skill, though, I guess I was fortunate because I worked directly under the CTO. So he, again, handled all the business stuff. I would sometimes have to be assertive in terms of what I was doing and justifying a business case and whatnot. But that's interesting. I can see there would be some probably smaller companies where if you're not working directly under an executive, it could be a lot more important. And there's a book by that you mentioned that quote, make sure you do the right work. And then I forgot the other part, but it was absolutely correct. There's a book by the Harvard Business Review. They write all these books about HR, like how to get the right mentoring, how to be a good manager, etc. They have one called How to Do the Right Work, or Doing the Right Work. And it's really important. It kind of goes back to your previous response, where you not to get carried away as a junior data scientist, doing all this stuff that isn't relevant. Make sure you're making the most impact. And at Facebook, that was kind of our big thing, was impact. Everything you do, you have to justify it with impact. So I'm kind of going to take that with me, even though I don't work there anymore. It's a pretty good way to summarize what type of work you should be doing.
Exactly. But the impact has to be relevant to somebody, right? So it really comes down to satisfying the needs of your client.
Yeah. So one question that I've gotten, I've started to get more, especially in the career track, is some people get overwhelmed about their role in the field. And some people are questioning, like, what niche should I be doing? Do I need to find a niche in order to get a job in this field? So, kind of going along with our previous discussion, is that really important for people coming out of this program to be specialists, or is it better for them to be generalists, in your opinion?
That's a very interesting question. Actually, I was corresponding with one of my mentees. I think she is here in the call about that. I didn't mention what I'm going to mention right now. But so there are two elements, right? There is the element of you being called a data scientist, right? So they don't call you a data scientist in marketing. They don't call you a data scientist in healthcare. They don't call you a data scientist in retail. They call you a data scientist. So that means that you're supposed to be equipped with the skills to work with other professionals to answer questions whose answers require the analysis of data. And these questions might belong to many different industry verticals, right? In my personal case, I'm essentially forced to have that stance because I'm a consultant. So I'm constantly looking for clients, and I cannot I cannot demand certain verticals from my clients, right? Because I mean, when you're an entrepreneur, the metaphor is that you're looking for somebody with pain, and then you're bringing the aspirin to them, right? You're bringing the something that is going to alleviate their pain. So so that's kind of the actual situation in some cases. Of course, it is possible. It's perfectly possible to because of all the clients that you have worked with, and because of your own professional interest, that you become specialized in certain areas, right? You can become specialized in healthcare. You can become specialized in marketing, sports analytics, etc. And that's perfectly all right. That's perfectly all right. It really depends on what is your strategy when you're planning or when you're thinking about your professional career, right? So, what are your goals, and then how do you think about the strategy you're going to follow in order to get to those goals? Of course, rarely in life things are that predictable, right? My wife always tells me, you always trying to solve the problem by coming up with an algorithm. And maybe that's the case because I've been doing this for such a long time. But I do recognize that rarely in life things happen that way. So we also need to be a little bit open to that randomness, right, that happens in life, and be open to, get into a vertical that maybe you might not like it at the beginning, but then you might like it because you get into it. So the advantages of being specialized is that you might become out of touch with other areas. And should you need to move to another vertical, then you might be in a little bit of trouble. But I mean, nothing is unsurmountable to that point. So it's a combination of your career goals, your personality, and what's the strategy that you follow in order to advance your professional career. But there are advantages and disadvantages to both cases.
Yeah, so I've heard the question phrased both in terms of the vertical, the field that you work in, and also the horizontal. So, like, should I study natural language processing or image processing or social network analysis? And usually, the advice that I give for both horizontal and vertical, well, I guess more for horizontal, is that you don't specialize for this role unless your vertical requires you to, or your company kind of requires you to, and you work there for a long time, or you have a PhD. So somebody who usually has a PhD has studied one particular area within statistics or computer science or whatever it is, and they may be hired to continue studying in that area, or it could be a completely different area from what they research, but they still have that specialized education where they can stay in one part of the data science process for a long time. So for me, it's sort of natural language processing. I do a bunch of other things, and I actually prefer to, change it up a little bit. But usually if you're coming into it not from academia, you usually start as a specialist, or a generalist, and then either stay as a generalist or make your way into a specialist eventually, where it's usually people who have done advanced research tend to specialize. But usually when you're hired, so like at Facebook, when we'd hire somebody, they would start out very rough around the edges, stuck in their world of their research, and then they have to be brought out and become more of a generalist. But because they have their research background, they're able to do that. They sort of know how to do experiments, how to work with data in a really intense fashion, the same way that a data scientist without that research experience would do.
Yeah, so I completely agree with you. One thing that I would add is that having a solid core of fundamental basic concepts is very important, because that's what will allow you to take those things that are fundamental and then go in different directions that are essentially applications of those fundamentals. Now, it is very difficult to get, like everything, all these core elements in one program like ours, or in any program for that matter. But the idea would be that you get kind of an initial version of it, and then you keep building on it. So if you're going to study because your professional practice requires you to do like package X, great, study package X, but if you have the time, then also pay attention to the concepts that are behind it that could be in package Y or another type of situation.
Exactly. Yeah. That's great advice. To always generalize yourself and not stick to one package or one particular model
Exactly.
with one theory.
Yeah.
So Lana has a question. Hi, Lana. Sorry, Lana. A lot of data scientists seem to come from a software engineering background. From your experience, what is the proportion of non-software engineers in the field? And what are some of the challenges that people from a non-software background face when entering the field or when already working in the field?
So I've actually seen quite of a mix, and I've actually been surprised that with the people that I'm interacting with right now, most of them don't come from the software field, which is an advantage to me because they hire me because I have those skills as well. So I don't think that I from my personal experience that is of course very limited. I can say that the majority of people that I interact with are originally from the software area. In terms of the challenges, I see data science as a continuum, and the continuum is delimited by the two ends of the spectrum that go from the question that the client has to the answer that's going to be given. And so in that continuum, there are different skill sets that are needed, all the way from just understanding what the problem is and making the connection between the business and the technical aspects of it, to the other side of things that has to do with actually visualizing the solution, right? So you might be using like a pretty complex neural network, but the output of that neural network needs to be visualized by a human being, and then you need to be able to present them in a way that is useful. So different elements in that continuum need different skills. So what I suggest to people is to try to understand the whole continuum in a generalistic kind of way, and then try to identify what are the skills in that continuum that are appealing to them, and then try to go in that direction. So there are people who only do visualization, and that's very complex. I mean, they don't have to worry about the algorithms, the neural networks, any of that stuff. They're very good at give me a bunch of data, and then I'll present it to you in a very usable way. And sometimes it's actually visually very, very pretty, right? We need people who actually understand the needs of the client, right? If you don't understand what the problem is, you might end up solving the wrong problem. And at that point, you might have lost a lot of money and nobody's going to be happy. So we need people who understand the needs of the client and be able to translate those needs to interface with the technical people. And in the continuum, I mean, I can mention very quickly, like a business analyst to get the requirements, maybe a statistical data scientist to understand or to explore what are the models that are appropriate for this scenario, and then testing these models in control environments with not a lot of data. And then there are the machine learning engineers and the infrastructure engineers who need to take those models and then take them to the extreme with large amounts of data. And then you have potentially the visualization engineers who are going to take the output of these models and are going to present them in a way that could be digested by the stakeholders. So there are many types of skills in data science. It's a really wide field, and you can use this. You can use our program to have this large view first, and then go deep into one or two areas, because you have to develop two different capstone courses. And then at that point, then you know in what direction you want to go.
Mm. Yeah, that's excellent advice. To kind of started it with the 30,000 foot view and kind of hone in on whichever part of the spectrum you end up going into. And it's kind of interesting. My story in the software engineering part was I got a master's in computer science because I liked coding, and I was interested in doing that for my life. However, as soon as you put that you have a master's degree in computer science, you almost automatically get pigeoned into a software engineer for data science. So you may be applying for a data scientist role, but very quickly you're going to end up on the extreme end of that spectrum. Not always. It could have been my communication skills, where I needed to be more assertive, like this isn't what I want to be doing type of thing. But it is pretty easy to get pigeonholed on that side of the spectrum if you have a lot of computer science experience or degree in it. So kind of going along with that, one fear that I've heard a lot from students is, how do they know by reading a job description for a data scientist? Because a lot of different kinds of data scientists job descriptions. How do you know if you're going to get pigeonholed, if you may get pigeonholed into an engineering role when really what you want to do is more insights or analytics?
Yeah. So unfortunately, getting a job is really messy. It's extremely messy. And maybe, honestly, from a philosophical perspective, maybe the best idea would be that, if you get a job, feel happy with it and try to use it in a positive way to advance your career. And the reason I'm saying this is because I've been on both sides of three perspectives of the spectrum. Obviously, I've been a candidate. I have advised people into how to evaluate the candidates. And I have been also advising like C-level people trying to determine what positions they should hire for, right? The fundamental thing that I've seen is that there's always a big disconnect between what usually are referred to as the hiring agent and the actual stakeholders that need the service that is going to be provided by a professional. A huge disconnect. To the point that sometimes it's just ridiculous, right? For instance, what I call the restaurant menu approach, right? Where they just run a system looking for key phrases in your resume, and then you get an email, asking you if you want to be a surgeon, right? So one day what happened to me is that there is a person that I work with, and it's my reference, and I put the name of the person. The name of the surname, the family name of the person is Hansen. And then a person calls me and say, we're calling you because you said in your resume that you know Hansen. And I said, yeah, I do. Do you know Peter as well? And she says, what are you talking about? And I said, Peter Hansen, the person that I referred to in my resume. And she says, oh, no, this is referring to a system that's called Hansen. So, it's as ridiculous as that. It can get very, very frustrating and all of that. Honestly, do you have control on whether or not they're going to pigeonhole you? Maybe not, because many times when you interview, people tell you, you're going to be doing this, you're going to be doing that, and we're now open this new initiative, and we want you to champion that. And then in practice, never that happens, right? Mm-hmm. So, they can say whatever they want, and what happens is sometimes out of your control. The only way that you can control that is if you are like an independent consultant, and then you decide whether you want to walk away or not, right? Mm-hmm. So it's very difficult it is very difficult to be able to control a situation in which you don't have a lot of control once you are in. The only control you have is whether or not you want to stay or not. But once you stay, what happens around that, you might not have a lot of control. So there's always the approach of, do the best you can with what you've got, right? And then sometimes people, obviously people get into positions where they would like to go, but they can't. You got to pay the bills, man. And if that's not the dream job, maybe the dream job will come if you continue pursuing it. So I guess that the way that I summarize it is by telling my mentees and everybody who cares to listen to this advice, 3 golden rules associated with job hunting. Number one, never take it personally. Number two, learn from every experience. Number three, never give up.
That's
That's
great
it.
advice.
And there are no guarantees, right? There are no guarantees that you're gonna get your dream job. And actually, I hate to be I don't know, ironic, but the older I get, the more I believe that there's not such a thing as a dream job.
Mm-hmm.
just because of the frame of mind associated with that, right?
Mm-hmm.
And that could be another talk more on philosophy, I think.
Yeah, and I guess it's good that I've learned that lesson somewhat. When I don't know, I don't consider myself young anymore, but now as opposed to 20 years from now, about the perfect dream job. I worked at my dream job had always been Google, and I haven't had a chance to work there yet, but I worked at Facebook, which is pretty close to it. And a lot of people would consider that their dream company or their dream job. And there were a lot of great things about working at Facebook, but thinking back on it, you think there was a lot of stuff that was really the same. Even though it was a great place to work, there were a lot of the same challenges you get at a place that wasn't a dream job. And there was a lot of stress that went into it. So I'm kind of jaded now on the idea of a dream job. And this is why people leave these companies. I mean, when I first joined, I said, how could anybody leave a company like Facebook or Google? And then I left. And, it's true. There really is. You have to make the best of what you have, because there really is no perfect job.
Yeah. I mean, my philosophy right now is that my dream job is a job where when I leave, things are better than when I got in. That I did something that's meaningful to my client, right? And they tell you, wow, I mean, before it was blah, 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 and now this is really good. Thank you. This is my dream job right now. The type of what I would consider to be my dream job.
So we still have 15 minutes left, everyone. So if you have a question, go ahead and type it into the chat and into the box in the chat area of the screen off to the right. You can also raise your hand in the system. If you don't know how to do that, because I don't remember how to do it off the top of my head, you can also get on your mic and ask a question. I want to see if anybody is off mute, because that means somebody has a question. Looks like everyone's still on mute. Okay, so either raise your hand or just jump in or click your mic or something so that I know somebody's out there. Don't be shy. Otherwise, I'll keep going.
Or maybe I put everybody to sleep. We don't know.
So one thing that's sort of come up in the past few years is this concept of having a project portfolio to get a job as a data scientist. What is your opinion about how important is it to have a portfolio? Are there particular candidates that you think could benefit from it? And what type of things should be in the portfolio?
Well, I mean, I know that these days, I'm going to come first from my original field, which is software engineering. I've seen the transition from the time when people ask you for your resume and a cover letter. Now they're asking you for your GitHub account, right? So that's kind of akin to a portfolio, right? It's a portfolio of software that you have developed. And I think that's migrating to pretty much every technical field, right? So therefore, it's almost like a de facto standard these days for technical fields where people actually want to see what you have done. So there's just no way around it, right? So and if you were to wear the shoes of the person trying to hire somebody, right? If you wanted to hire somebody to cook for you because you have a restaurant, resume is great. Reference letters are okay as well, but you want to see if the person can make a pretty darn good key lime pie, just to say something that I like, right? So the same happens with us looking for a job. So if somebody wants you to be able to do an A/B test, be able to understand how to do it and how to interpret the results, what's the best way that you can do is show them, a project when you yourself did the A/B test, which is another thing that has to do with everybody, who writes about how to do interviewing, etc. They're interested in what you have done, not so much what project you worked in, but what were your personal contributions to the project.
Mm-hmm.
So in the absence of actual projects associated with real clients, companies, etc., what is the best next thing? Project, right? And if the project is very realistic, then it could almost equate to an actual project that you have developed for a client, right? Depending on the levels of complexity, etc. But in the absence of everything else, the best thing you can show is your portfolio.
Mm-hmm. Yeah, and your portfolio comes in a variety of forms. So GitHub is probably the most obvious. In my case, I was more of I started out more as an insights analytics guy. And I guess the degree ended up putting me more on the engineering side. But my portfolio at the time when I started was a blog. So blogs are a good way as well, as long as you show enough technical depth in your blog. That could count as a portfolio as well. But I know when I finish this dissertation, all of my code is going to be cleaned up and put onto GitHub. That's going to be my portfolio for this last 2 years that I've been consulting, because you can't always share. So another interesting point is that if you work in industry already and you're trying to switch to data science, you can't always share your code or your data if it's proprietary. So you have to kind of get creative and maybe work on some projects on the side and whatnot. So if you're in that situation, get creative.
Yeah, I agree. That's a very good point. And that's why this type of a program is very good, because you'll be building something you can definitely share publicly, right? It is in your best interest to do that. But certainly, I've been in interviews where I have to say, unfortunately, I cannot share too many details about this, but then I have to be very generic about what I did, and then try to, focus the attention to things that could be explained without having to reveal too many details, because you are contractually obliged to not reveal these details, right?
Mm-hmm. I apologize if I butcher your name, and I apologize to anyone if I ever butcher your name. Fazy's question is, are there, I think this goes back to an earlier discussion, are there specializations in data science? And so he or she lists NLP, neural networks, marketing, finance. And what are the tasks / algorithms, etc., that every data science is expected to have a competency in?
So to the first question, yes, definitely. With like in any professional field, there are always people who are very specialized in certain areas. And the cases that I know of, they usually work for large companies that they have a lot of resources to invest into that type of an area. Examples include, for instance, from friends that I know, places like GE, this large company that does petroleum exploration is called Schlumberger. Those are like very well-defined verticals, and they want people who know the specific algorithms for this type of situations that happen in that vertical. And we already commented on, the pluses and the minuses of that. If you spend like 10 years in a company like this, and for whatever reason you find yourself out of a job, then you might have a little bit of trouble, getting back if it's not a company, like that. And the thing about those companies is there are only very few of them, the ones that are large and very specialized, right? In terms of the other question about what are examples of algorithms that every data scientist should have under their belt, I would be leaning more toward fundamental concepts, right? So, for instance, in data science, there's always the statistical view of things and the mathematical modeling view of things, right? So you can approach the problem as a problem of trying to find, simulate, or estimate a certain random variable according to certain distributions and properties, right? And then you pose a problem from a statistical point of view. Or you can see it from a strictly mathematical modeling perspective, where you try to cast a problem as one of optimizing a certain cost function, right? Practically speaking, both problems are the same, and a beautiful example would be regression, right? This is very manageable. Try to understand the perspective of posing the problem from a statistical point of view, which is looking at the maximum likelihood, right? And also from the perspective of a mathematical modeling perspective, which calls for optimizing a certain cost function. When it comes to applying the algorithms, the results are going to be the same, but the approach is different, right? So there will always be this two ways of seeing the problems, from a statistical point of view and from a mathematical modeling objective function optimization point of view. When you get the chance, try to kind of see the two perspectives. Those are fundamental concepts that would allow you to walk. So there are many, for instance, absolutely all the algorithms that we study in the Coursera machine learning course can be seen from the perspective of solving an optimization problem, mathematical optimization problem. So having that understanding helps you use that as a general framework that allows you to kind of see different situations in the field of practice. The same would happen from the perspective of the statistical frame of mind when it comes to posing problems. And then within statistics, there's all this discussion about frequentists and Bayesians, and there are other categories that I'm learning nowadays that I don't even remember what they are, But I think that if you couple those fundamental concepts with the goal of you need to help people solve problems in a practical way, the combination is pretty interesting.
Mm-hmm. Yeah, it's you point out you make a really good point. And so in this course, you learn a lot of different kinds of models. And when I was very early on in this field, even as I was working in the field as a junior data scientist, I had this mindset of thinking of things in terms of a taxonomy. There's KNN, there's naive Bayes, there's logistic regression. There's this list of algorithms that you can use. And that's great if you understand them. But then once you understand them, you should then learn what's actually happening. Well, not just what's happening behind the scenes, but boil it all down into one field. So in this case, it'd be mathematics and optimization. Really, that's all you're doing. Each problem has a different optimization that you're making, maybe a different loss function, or a different way of measuring loss. And that's really all the differences among these other methods. I'm probably overgeneralizing, but more or less, you have a framework there. For example, the general linear model, you have linear regression, logistic regression, and a million other types, and you can memorize them like I did. But really, all you need to understand is that there's these assumptions about the residuals and the relationship between the variables that helps you choose which GLM to use. So if you understand that, you'll be more successful than just memorizing a bunch of different things.
Yeah, I mean, I come from a school of thought from very early in my education that was against memorization.
Yeah.
So that actually worked a little bit against me because I never remember anything just because I didn't practice my memory. So I come from the school of thought of knowing fundamental concepts and building everything from it, right? So I was very influenced by that school of thought. So memorization to me has always been kind of a no-no. Because then you need to understand how to build the stuff, right? But it is okay. It is okay. This is something I tell my mentees too, to have what I call the black box or the Lego bucket approach to solving problems, right? Which is that you have a set of tools, and then as long as you understand from your Lego box what a certain piece does, and you know how to connect it appropriately with other pieces, that's okay too, because you're solving the problem in an effective way. By the same token, that every time that you turn on your car, you're not really solving, partial differential equations about everything that is happening in there, right? And you get the job done. It's okay to do it that way, but there's a certain level of understanding of what the black box does. So to identify what for what problems this black box is good, what are the limitations of the black box, and how do I interpret the results that are going to come out of the black box in different types of scenarios. Mm-hmm. I think somebody's asking a question through the chat.
Yeah, and just kind of going off of that, you worded it better than I do. I don't mean memorization. I took more of the Lego bucket approach, where I didn't understand maybe all the math and loss function behind it, but I understood how the pieces go together. But really quickly, we have one last question from Manyan. How do you visualize and plan for resources and efforts needed that are minimal to accomplish a data science project with a lean team? So in other words, the question is about resource allocation if you have a small team. Then he also asks, they have very minimal resources, it looks like. How do we align business objective goal with data without spending much on the technology? So in other words, how do you get the most bang for your buck, essentially? How do you plan it and get clever with resource allocation is what I think he's asking.
Well, that's the $20,000 question, right? It's almost like a question you would ask a consultant. Mm-hmm. So I can send you my card if you want to hire me. No, I'm just kidding. But it seems that this is more project management type of a question, right? Yeah. Where you want to align your business goals with the problem, etc. Right? So I mean, the shortest approach that I would put forward would be to try to visualize this continuum, right? Between what are the questions that are being asked and how do I get to answers, right? And then start filling the gap between point A and point B. And then and there are of course, different things that people have tried over the years. For instance, one idea is the agile development of things, right? Like lean startup or things like that. All of them are variations of the same idea, which is that if you want to go from point A to point B by building something, something could be a product, software, whatever. Don't try to get from A to B in just one jump. Try to get from A to B in smaller iterations, right? So that's incremental and iterative development, right? Agile development. And then depending on what we're talking about, then it would be important to talk about things like how the product, what is the relationship between the product and the market, that kind of stuff. I mean, it's a pretty complex question. It has a lot of buzzwords in it. Sorry if I'm not covering all of them.
The most comprehensive answer would be to hire a product manager.
Well, that's one element, yes, but you need the whole team, right? You need the people who are going to do the development, the people who need to understand what needs to be developed, and then you need management to be to make sure that you get this stuff done correctly and you build the correct stuff.
All right, so we've hit 6 o'clock. Awesome questions, everyone. Awesome, responses. I think you gave the mentees a lot to think about. A lot of good advice and other comments and whatnot. If you have any questions for AJ, you can contact him on actually not Slack, on the new data.
The message board.
The new community. There's an IM function that I just learned about.
Yeah.
IM mean I had no idea what that was about, but there is an IM function there, so you can IM him any questions you have. Otherwise we will see you all next week. I'm not sure what next week's topic is quite yet. Maybe a project presentation, but we will all let you know. Kane will let you know. Thank you so much, AJ. Thank you, everybody, for coming.
Thank you.
Have a great rest.
Thank you, everybody.
And see you all next week. Thank you.
Thank you, Ryan, and thank you, everybody. Have a good night.